I'm going to explain how to find the probability of normally distributed information. So, if any random variable x is normally distributed, you can find the probability that x will fall in a given interval by calculating the area under the normal curve for the given interval. To find the area under any normal curve, you can first convert the upper and lower bounds of the interval to z-scores, then use a standard normal distribution to find the area. So what that means is that just by using the mu, the standard deviation, the z-score, and by knowing what your your random variable x is, you can find the probability of the random variable x. This only works for if the information is normally distributed. First example is gonna be from a word problem. So if a survey indicates that people use their computers an average of 2.4 years before upgrading to a new machine, the standard deviation is 0.5 years. A computer owner is selected at random. Find the probability that he or she will use it for fewer than 2 years before upgrading. Assume that the variable x is normally distributed. Okay, so the mean is given, so that's 2.4 years. The standard deviation is 0.5 years. So our x is going to be 2. So we're trying to find the probability that people are going to upgrade their computer under 2 years. So x is less than 2. First we're going to find the z-score of x, and we know that the equation for that is z equals x minus mu over the standard deviation. So we're going to fill that in, and that's going to be 2 minus the mean 2.4 over 0.5, 0.8. So what we're going to do now is we're going to go to the table and we're going to look for negative 0.8. It says that it's 0.2119, so that's our percentage. 21.19% of the people under 2 years, they go and upgrade their computers, and that's the answer. We're gonna do a different problem now. This problem isn't a word problem. This problem just gives you the probability. So this is going to tell us to find the probability of x being greater than 92. Before we were told this, we were told that the mu is 86. The standard deviation is 5. So what I usually do here is I'll make a small graph so I could visualize it. It's a lot easier. So I know this here is my mu and 92, and everything that's greater than 92 is what I want to know. So this is what I'm trying to find out. So we're going to go and use our equation for z-score again. So x, which is 92, minus the mu, which is 86, over the standard deviation, which is 5, is going to be 1.2. So we're going to go do the same thing again. But this time, because we're looking for what's to the right, we're going to look for what's under what the z-score for negative 1.2 is, because when it gives you this, if I go search for this z-score, it's going to give me everything that's to the left, but I want everything that's to the right. So I'm going to look for negative 1.2 instead. So we're going to go here, and it says that it's 0.1151. And that's our answer. Probability of 70 being less than x, but x being greater than, being less than 80. So we're going to make a small graph to see what this looks like again. So we're going to use the same information from the last problem, the mu being 86 and the standard deviation being 5. So here's 86, and 70 would be over here, and our 80, we'll have it right here. So we're trying to find that everything that x is greater than 70, so it should be everything to this side, and x is less than 80, so it should be everything to this side. So this is what we're trying to find out. Now what I do now is that I treat this as two separate equations, because we have to subtract them later on. So it's easier to just treat them as two separate equations. So the first one would be probability of 70 being less than x. And then we're going to have the probability of x being less than 80. So first we're going to do this one. We're going to use our equation. 70 is our x minus mu, which is 86 over standard deviation 5. So this is going to be negative 3.2. And if we go to our chart to negative 3.2, and we're going to look for negative 3.2 and not 3.2 like I had said before, because remember, this equation is telling you that everything that is greater than 70, everything is going to the right, is what we're looking for. But what we're going to do, because even though we're using them as two different probabilities, they are going to be together at the end. So we're going to just look for negative 3.2, and later on when they're subtracted, it'll make sense. So negative 3.2 is, the z-score is 0.0007. Okay, so we're going to do the next one now. So x is 80, and minus 86, which is a mu, and the standard over the standard deviation 5. Answer to this is negative 1.2. So we're going to look for that in our chart, and that's 0.1151. Okay, now you're going to see what I'm talking about having to subtract them. Because this is everything that's to this side. Well, this is everything that's from 80 down, and this is everything from 70 down. You're going to subtract them both, so it gives you this. So you're going to subtract from 0.1151, you're going to subtract 0.007, which is 0.1144. So the answer to this is 11.44% is here.